Another video is going to be a manual soldering video. This one is going to be manually soldering chips with an iron and wire, and then I'm going to do another one that's soldering manually with paste. So for this one, we're just going to put an op-amp chip on here. So I had just done a stencil on this one for this chip. We're going to put an op-amp on the other remaining port here. I apologize too because I don't have really fine pitch parts on my board. And if I probably should have added that, that probably would have been a little better if I had done that. But I mean, everything we do for these, it's the same thing for any others, it's just a little more work. So one thing I wanted to mention too is we can see it here. A lot of students, if you have one of these op amps, there's difficulty sometimes finding pin 1. So here you can see there's a little dot. It's not always that clear. So sometimes it's not that obvious that there's the dot there. And a lot of times what you want to do then is look for the flat side. So if you look at this, you see how there's a kind of a dark side on this side of the board. There's like a little, it looks a little darker than on the other side. And you might just think, oh, that's just the way the light is shining. But if we rotate it around, you still see that dark part over here. So what's happening is one side of this op amp, the corner of it is at a 45-degree angle. And so it's kind of cut. It's kind of, I don't know if it's easy to see if we do this, but nope, it's very, very not easy to see. But one side basically has a, I wonder if we can, let's see what we can do here. Let's see. There's magic we can. This one was already, this one's pre-soldered here, but can you see? Oh. Yeah, it's not super clear on this one. Let's the better one here. You can see one side has, you can see it here, right? See, one side is more of an angle. See, the left side there is more of an angle than the right side. It's because that corner is sort of chopped off. That corner is chopped off at an angle. And that can be used to determine your pin 1 too. So your pin 1's always going to be on that side that has the flat spot like that. So let's keep this as is. So if you don't see a dot, look for the flat spot. That's the side that, and normally you only have a flat spot on a part that's only, its positioning is only ambiguous in 2 directions. So if it's a bigger thing than that, then it's probably not a thing. Okay, so I'm gonna refocus this. Okay, and I'm gonna, so it's, I get a lot of glare when I have the light on here, so I'm gonna redo it. The problem is when I do it like this, you can see it better, but it's kind of dark and. Okay, so we're gonna manually solder this thing. So we got it sort of generally aligned, and there's a couple mistakes students make when they manually solder. The biggest mistake they make is as soon as you get solder on more than one pin, there's no real going back to changing the shape. So as soon as you get solder on more than one pin and you need to reorient it or tweak it a little bit, your only real choice is to kind of pull the whole thing off. Because once it's very difficult to apply heat to more than one pin with one soldering iron. So get it aligned with one pin, do all your adjusting when there's one pin on there, and then go from there. The other thing is not enough flux. So we're gonna try to be careful with flux. So the first thing I'm gonna do, I'm gonna actually take the part off here. The first thing I like to do, especially when we're soldering with, especially when we're not using paste, because the solder itself has no real flux, I like to just put a big old glob of flux on here. So I'm just putting flux. So I'm going to sort of put a bed of flux on this everywhere where the pins are going to go. So every pad is going to get flux. And you can probably even do even more than that and it would be just fine. So a whole lot of flux there. And then now I'm going to put the part back on there. Put the part back on there. Adjust it. We're just going to adjust it, get it roughly in the right spot. Push down on the top too. It's really easy for parts. Sometimes you'll have a little goober under a pin or something like that, and it'll get off, and it's really easy for that to happen. So we're going to use a manual iron. We have a clean tip. It's not a great tip because I just put a crappy one back in there, but that's good. It's closer to what you might experience. And then so I'm going to I'm going to show you. So I'm going to get a little bit of solder on the tip here. So just put some solder on the tip. All right, just to get a little ball. You just want a little ball of solder there on the tip. You can see it in the microscope here. A little ball of solder there on the tip. Turn the light here. Get a little ball of solder on the tip. Yeah. Okay. So what we're going to do is just with the tweezers sort of holding the part kind of in place, we're just going to solder one pin with this. We're just going to take this, hold it in place, and boom, just hit one pin. Oh, didn't quite do it. So boom. See that? See how once I actually got the pin, it kind of sucked the solder up there? Yeah. So once we actually got it, it kind of sucked the solder up there. And one mistake students make is they don't hold the solder long enough. You don't want to let the heat stay on there for a really long time, but you also don't want to do it too quick. If you do it too quick, you're not going to fully melt that little wad of solder there. If you do it too fast, you're just going to sort of melt a little section into it, right? So we're trying to, you want to apply enough heat to fully melt the butter. You don't just want to kind of like, make a little pool in it, right? So I'm going to deliberately mess this up though, right? So let's say, okay, so we had done that. So we had soldered and we'd say, oh, that's bad, right? So our part's off. It's a lot easier to see without the ring light. So our part's way misaligned. But the nice thing is now we only have one pad misaligned. So from here, all we have to do to fix this is put heat on that one pad and then nudge it back. So put heat on that pad, nudge it back into place. So it's not, we can even grab the whole thing while putting heat on there. The main thing is just be gentle. I actually prefer to just kind of tap. I don't like to squeeze the sides of it and grab it because it's really easy to rip a whole pad that way. Just do a little something like that and just get a tap, right? So you see now, if I give it a little touch, it'll move it, but it's anchored by that one pad. I don't want to push too hard. Right? So it's aligned in place now by that one pad. And so the next thing we want to do is just once it's aligned in place and we know it's where we want, I always like to check to make sure it's down on the surface. It is possible when you're soldering a part to have part of it be lifted up, and it's very difficult to see that something's lifted up from the camera because the camera's top-down view. So I always like to just push on while it's in place, push on the top, remelt the pad, and it felt like it was down, but sometimes if it's lifted up, it'll sort of pop back down. We can deliberately cause that to happen. So okay, so here, right, it looks kind of like it's okay, but actually this is off the surface. Oops, no, it's not. Okay, so yeah, it looks like it's aligned, but it's not, right? You see this part, it's floating off the surface. Looks good from the top view. Looks good from the top view, but it's not. So we can slide a stencil underneath it. So in this case, so again, we want to make sure that it's pushed down. The best way to do it, I found, just gentle touch on the top. Reheat, let it pop down while holding pressure on the top. And you want to hold that pressure through until it cools. So you don't just want to, when the solder's wet, everything can move around. So hold pressure, hold it steady, release the solder, let it cool down. So let it at least crystallize. You can kind of see it kind of goes from being shiny to being a little dull. At least when it's lead-free solder, it does that. So, okay, so now that it's in place, we want to just do one more pin. So we want to get one more pin. So we soldered that top right pin. Let's do the bottom left pin now. We already did flux, so we're not going to do that. Um, but we don't have to add that flux to the. We don't have to add the solder to the tip now. Now we can just do it the normal way, which is feed the solder in while it's there. So, oh, see, okay, looks good. It can be a little tough to see if a pad is on there, but if the chip is pushed all the way to the surface, which this one is, then pretty much if the solder is like that, it's good. If you're really worried about its connection and you want to add more solder to really get a nice ball on there, that's obvious needed. But okay, now for the rest of this, there's the main thing is you're soldering the chip is on there good now. There's no way to move it now. We got 2 pins down. There's no way to move it. If we wanted to adjust this at all, we'd have to do hot air. So now what we can do is we can just come in here and just start feeding solder and apply the solder. So we're just going to go into each pin, and actually once I get some on the tip, I like to do this. I like to just come up and touch each of these pads, right? And so you can kind of watch it. As I do that, you can watch it kind of, oops. I'll get one from the other side so you can see it. Let's do one on this side. That pad on there. Great. Lighting is not super great here. Better. All right, so now what I'm going to do is I'm just going to, just with a little bit of solder on the tip, I'm going to show you what it looks like. So as you move it in, yep, you see that solder suck up there? So plot. So I still have enough solder on the tip now to hit these pins. So I just keep, this is a cup, this pin, this tip has a lot of solder and a cup on the tip. Should keep on touching it, let it soak that up. Looks great. And I'm also going to go back to that first pin that I had. That first pin that I had already soldered. I'm going to go back to it. Yeah, so these all look good. Now I'm going to show you a common issue people have. Probably the most common is bridging. So I'm going to create a bridge. And it can be tough to create a bridge if you use a lot of flux. If you use a lot of flux like I did, well, it wasn't that tough to create a bridge. Okay, so we got a bridge now. What do we do? So create a bridge. The first thing to do is get any excess solder off your tip. So use the sponge. Use the sponge. The sponge is for cleaning off excess solder. The braid, the solder braid that's at a solder station, that's the brass, like little, looks like a Brillo pad of brass. That is for cleaning off the. So that's when you get residue on the tip that won't come off. That's like kind of like for aggressively sanding off the tip. A lot of students have a big clump of solder and they'll stick it in that brass braid. That's not the place to do it. The sponge is where you want to wipe off the excess solder. The braid you only use if you need to get that tip clean and shiny. So think of the braid as like if your tip starts to get gnarly and the water and the wet sponge won't clean it off, you kind of want to give it, just kind of spread, give it a couple little taps inside that brass to really suck off everything else and scrape off the rest of the junk that's on there. Okay, so we got a bridge now though, and so we're gonna get it off. There's a couple ways to do it. One way you can do it sometimes is just with the iron, right? Once you get the iron clean, if you retouch the iron to it, quite often that alone will be enough to pull that off. So a clean iron will sort of suck up a certain amount of solder, and so sometimes that'll work. So let's give that a try. So clean iron, and I kind of like just see when I first touch it, it doesn't melt it. It takes a little while to melt it. So when you get this much solder, it's going to take a while to actually get enough heat in there. Sometimes you got to kind of scratch the surface to get some surface area. So, but just gently, everything's gentle. So we touch the iron here. Oh boy, this one's not wanting to melt. There we go. As soon as it melts, and it goes. So I'm going to kind of brush it like this. And can't quite do it. Maybe I clean it off one more time. Get heat in there. Just hold it. As soon as it starts to melt a little bit, usually it makes a lot of surface contact and then it'll melt the rest. But for now, This one's kind of being a pain. I don't want to scratch too hard, but you got to get that surface area. There we go. Okay. Yep. So there we go. So I just kind of brushed it and it eventually did break that bridge. We're going to put the bridge back now. I'm going to show you the other way. If you have a stubborn bridge that won't just fix like that, the other way to fix it is with braid. So the main thing with braid, always flux your braid. So I'm going to just jab the braid into the, we're kind of down to the janky flux left. I'm just going to stab the braid into the flux, and then you're going to set the flux on the bridge. Apply heat to the flux. Be careful not to burn your fingers because this heat's going to travel up the copper pretty fast. So we're going to apply heat to the flux braid, with lots of flux on the braid itself. Hold it there. You gotta really pay attention. You'll kind of feel when it gives. Yeah, so it's starting to give. You'll see that metal kind of start wicking up the braid. The copper color will start to turn silver. Keep heat on there. This is taking a very long time. This pin must be really, really thermally conductive, right? So this is, okay, there we go. Whoa, you see that? It sucked it up. Now, a lot of times after students use braid, they think, oh, I sucked all my solder off the pads. So a lot of times after they use braid, they think, I don't have a solder connection anymore. If the part was on the surface, that's not usually true. If the part was actually on the surface, normally there will still be solder there, even if you can't see it very well. So odds are this thing still has a solder connection. It just might be a little difficult to see. So let's see if we can get this in an angle here. Yeah. So this looks to me, I don't know how well you can see that. That looks to me like there is still solder connection. It's just kind of just barely in that kind of meniscus edge there. So it's difficult to see. Let's turn on this light. Sweaty armpit here. Gross. It's not my fault, it's Rez's fault. I walked down to the village with him for lunch, so anytime I accidentally get any exercise, it's usually Rez's fault because we walk somewhere for lunch. So please blame him for you paying for my Social Security for many decades because I didn't die early because I got exercise. But for now, you get a sweaty armpit right in the computer camera. Okay. Yeah, that didn't help actually. You can't see it. Yeah, but anyway, so those are soldered. So that's still good. That's not always the case. Sometimes you do suck the solder off of it, and it's just not good. Sometimes you do take too much off. Okay, so let's zoom out. So if you do take too much off, it's not a big deal, right? So you took a little too much off. But we'll go back to our normal process. Hit it with some solder. Okay, so, and you know, a lot of people like to, after they get all the pins soldered, sometimes they just kind of go through and they'll just kind of give them a little scrape, right? If you have fine pitch pins, a lot of times you have to kind of just do this. You kind of just have to just gently run the iron over all the pins to kind of reflow that, sort of even out, distribute the solder, reflow the solder. Now, these ones are holding their heat pretty well though, so it didn't really help too much. All right, and that's that. All right. There's another video that I posted about desoldering these things with hot air. So, you know, kind of go through this same process but in reverse. So thanks for watching.